I started to outgrow the space I had in my shop, but I desperately needed a big CNC machine for plasma, wood routing. I mean, of course, I wanted everything. But the narrowness of the shop, that's the only workspace, open workspace I had available. So it's really the only place I could put a big table, but of course then I wouldn't be able to walk around. So I ended up spending the last 2 years developing this machine. I built several iterations of it. I changed the design numerous times. Um, it has 50 inches of Y travel, 50 of Z, and 100 inches of X travel. Top speed's about 600 or 700 inches per minute. I don't run it that fast. On the Y-axis, it's got coolant and power and tool changer and a rotary table axis. The tables were a big challenge. I needed to have the ability to change the table's characteristics based on the tool that was installed. For example, on a plasma cutter, I needed metal slats. On a wood router, I needed spoil board. And on a drill, I needed a nice flat surface. So the tables are 4 foot by 2 foot sections that are open framed, and then you just put in the insert necessary. There is the spoil board frame, jig I call them, or insert. The one hanging on the wall has the plasma insert, or maybe you use that for welding as well. It's metal slat inserts. There's no reason you can't put slats in all of them, or wood in all of them, but I generally don't use much more than 4 foot by 2 foot. Sometimes 4x4s. There's an example of a 4x4. Just the sections. They're symmetrical. I've worked on a lot of tool holders. I'm now in the process of collapsing them, sharing commonalities between them and getting rid of a few. Some of the tool holders are pretty heavy, and so I just bring the mill into position. I added a rotary attachment. This is particularly useful for the MIG welder, for getting the MIG nozzle into crevices that you want to get the bead angled properly. And operates just like a rotary table, A-axis. The original tool holders were individually designed. Like that one, for example, was the original wood router. The other one is the original MIG slash plasma tool holder. They're lightweight, they're easy to build. Then I switched to this, not necessarily for the longer reach, but for the fact that it has a shorter replaceable end effector. The main unit rotates 90 degrees and gives about 18 inches of travel off the tool. What's on there now is the MIG plasma tool holder, and then the wood router just bolts on in place of it, so it makes it a little easier to change the tools. And that's an example of how the MIG or the plasma cutter gets attached to it. That's fewer tool holders is good. I started to have quite the collection of them. This has been the biggest challenge, the rigid tapper and the high torque drill. I wanted to swing some big annular cutters. I also wanted an automatic tool changer. Turns out I don't really use an automatic tool changer. I use it in manual mode, but there's no reason you can't hook a solenoid up to it and activate it with M6. The tool holder's kind of heavy, so that's how I actually mount it to the machine, by bringing it into position like that. Uses an R8 collet that has the Tormach tool system in it. The cylinder, of course, is the automatic tool changer, and the Belleville washers keep it compressed. There's the manual switch I use to change tools. It's geared down with a pulley system, and that large block of aluminum contains two tapered roller bearing on either end, large tapered roller bearings actually. It's always been a desire to make the thing do a little bit of light milling, along the lines of like my TEG machine. I've had TEGs over the years and I like them, and they're not super powerful, but they can get a job done. So I added ball screws, kept them where the machine was most rigid. That's about a 22-inch travel screw, but I consider it a 20. And It does mill steel with it. In fact, the large reach tool holder was, the slots were milled out with this machine. That's the X-axis ball screw. It's 32 inches. So I consider it a 30 by 20 inch mill, and it's handy for being able to do light milling work. This is not by any means going to stack up to a Haas or something like that. Of all the vacuum systems I've seen, they always seem like they're in the way or clumsy or ugly, but I knew that I would have to have a vacuum system constantly incorporated into it, so I would always use it. So I went with this slinky style design. The X, Y, and Z have a built-in hose, each of them, and it moves with the axis. Makes it very easy to use it for welding gases, plasma gases, wood routing. I don't do metal chip collection with it. I just use the air to blow those away. But very handy to have. And the most important part is I can still use the space where the machine exists because the machine completely folds up out of the way. So when I'm not using it, I've got all that workspace left.